Right, hello again grade 12s. We're continuing with our section on trigonometric measurement, and specifically we're working in 3 dimensions, also called solving problems in 2 planes. And those 2 planes generally refer to the horizontal plane and then to the vertical plane, as I explained to you in the previous video. Okay, I have already given these tips in the previous video where it says whenever you're trying to solve 3D trig problems, specifically solving problems in 2 planes, please remember, always start with a triangle that has 3 values or given variables. So that means you either have 3 sides, you have 2 sides and an included angle, 2 sides and an excluded angle, 2 angles and an included or an excluded side. But the point is, you're always going to start with a triangle where you have those 3 pieces of information. Why? So you can actually do a calculation. Because if you don't have 3 pieces of information in trigonometry, you can't do a calculation. Then, determine the side or angle that overlaps with the triangle in which the requested angle or side is located. So you're always going to start with this triangle, but you're going to always work towards the side that overlaps with the triangle in which you are trying to solve that angle or that side, depending on what was asked. So, just continuing with examples. Now, these particular examples, you'll see, they are quite tough. So I just want to start off and say very clearly these are tough examples. And the reason these are tough examples is because they contain quite a few variables and pretty much no unknowns. So when in this problem, which is example 1 on page 160, they state AB over here is a building which is then perpendicular to the horizontal plane. And you'll notice I've colored it in like I did in the previous videos as well. It's just easier to color in the horizontal plane so you know where the ground is. Okay. Now it says the angle of elevation from C, so when you look from C, a point in the horizontal plane to the top of the building is theta. So right over there, I know it's a little bit unclear, but that is my angle of elevation, which is theta. Angle BCD, so over here, angle B to C to D, that is angle beta in that horizontal plane. And angle B to D to C, that is angle alpha in that horizontal plane. And then they tell you the distance between point C and D, which are also in the horizontal plane, is k meters. Now, this is what makes these problems so tricky. Everything, tricky. Sorry about that. So, pretty much what happens here is we are going to have to carry these variables throughout the entire solution. And I know how little you guys like variables, and now you have 1, 2, 3, 4 variables that you're going to keep on carrying forward into the entire solution. So yes, I agree that is not easy to do. A couple of things though, the method stays exactly the same. So the method that I described here, we're going to employ here. That's the first thing. But there's some good news, and the good news is the IEB in general don't ask these in exams. They ask different types. They like asking questions where you have values and you can calculate something. So we will do examples that are more like the IB papers later on in this week. But first I need to discuss these ones with you just to make sure that you do understand this technique. But just because they don't generally ask it in the IB doesn't mean they can't. Okay, so in this particular one, we start in this bottom triangle and we clearly state in triangle B to C to D. There you go. And then, like I stated, we want to go and we want to calculate an overlapping side. And I can even predict which overlapping side it must be. It must be this one over here. And that is simply because this triangle over there in the vertical plane, that triangle ABC, has got an angle of elevation theta. Whereas if I work towards this side, that triangle there does not have that angle of elevation. So there's almost no information in this triangle. That's why I will work towards that triangle, triangle ABC, and I won't work towards triangle ABD. So it's very important that you plan these things. Okay, so in triangle BCD, we've got 2 angles and an included side. Now, hopefully you guys should remember from the grade 11 revision that we did that this is going to be the sine rule. But this is a very slightly tricky sine rule in the sense that we can't actually use 2 angles and an included side. We first have to go and calculate this angle up here by using sum of angles of a triangle, so that I then move to 2 angles and an excluded side. So that's always going to be our first little step. So we're first going to start by saying angle CBD is then going to be equal to 180 degrees minus alpha minus beta. And that's because of interior angles per triangle, or sum of angles per triangle, whichever way you like to write it. Now please note, I will always clean this up, and there's a good reason where I clean it up, you'll see just now, by putting the minus over there and then making this alpha plus beta, which because of the brackets distributively, those two are equal. Okay, now what we're going to say is we're using the sine rule, and we're specifically using the sine rule to calculate that BC. So we're saying BC over the sine of the opposite angle, which is alpha, is then going to be equal to K, which is that given little side, over the sine of the opposite angle, which is this one that I've just calculated. And hopefully you guys will then notice this is why I rewrote this. That's why I didn't keep it 180 degrees minus alpha minus beta. I changed it to 180 degrees minus alpha plus beta because that is a reduction formula. Specifically, it's a reduction formula for the second quadrant, and in the second quadrant, sine is positive. So I can throw away that 180 degrees minus, and I can just change it into the sine of alpha plus beta. So that means BC is equal to K times the sine of alpha over, and like I said, that reduction formula, I can then just go and say it's then the sine of alpha plus beta, which is positive in that second quadrant. Now obviously we're not done, because we still need to go and calculate AB. I've just now gone and I've calculated that overlapping side, but now I can go and I can move on to the next triangle, which is in the vertical plane. So let's do it like this. So I clearly state in triangle ABC. And like I said, if you are worried that you can't really see what's going on, you can then go and you can redraw this triangle just again to get more of that side on view. So you can look at it straight. So like that. And then say this is A, this is B, there's 90 degree, that's C. Okay. And then we've got that angle of elevation theta over there. So it might just be easier to redraw it, remembering that we've already calculated over here BC in terms of those variables. Okay. So now I can go and I can say in that particular triangle I've got BC, which is my adjacent. I want AB, which is my opposite. And again, opposite of adjacent is tan. So tan of theta is then going to be equal to AB over BC. And note that for now I'm just going to write the BC down. I'll go and the information that I've gotten in that previous calculation, this information, I will carry it over just now. But for now, just to keep it nice and neat, I'm going to do this. And I'm going to say that means that AB is then equal to BC times the tan of theta. And then I'm going to take all of that information that I calculated in the previous triangle. So all of this, that, and I'm going to carry it into this. So I'm going to say that's then K times the sine of alpha over the sine of alpha plus beta times then the tan of theta. So I can just go and put that tan of theta at the top. And that then is my answer, because they asked you to please go and calculate the height of building AB in terms of K, alpha, beta, and theta, which I have done. Okay, so this is what makes these ones slightly confusing, is you go and you say, but I haven't gotten an answer. You haven't gotten an answer, but you have an expression with which you can find the answer. So if they now suddenly go, and this happens a lot of time as a follow-up question, they tell you if K is 10, alpha is 30 degrees, theta is 10, 20 degrees. If they give you these values, you can just sub the values in there, type it into your calculator, press equal, and you can actually go and calculate this. So it's not impossible to do. You obviously will then just have to go and you'll have to do that. Okay. Now, I'm going to look at an example over here, and this is just, again, to like I stated earlier, where I said that even though most of the homework that I'm going to be giving you, because the exercises are set up like this, include these type of examples where I end up with an answer that's got a bunch of variables in there. So yes, you're going to do lots of this in the homework just to be able to do this technique. But I want to go to the IB papers, because as I explained to you in the video earlier, that the IB papers don't really like asking these questions with all the variables. So every now and again, I'm just going to quickly refer to an IB question so you can see how this one is asked. Now this one is the IB National Senior Certificate, so the final exam paper 2, November 2018, and it's question 8C. And they give me the following information. They say in this triangle, FW is 6 units over here, FG is the square root of 116 units up here, angle GWH, so from G to W to H, is 45 degrees over there, and they're asking you calculate GH. So that's what you want to calculate. Now this one, for instance, even though it was asked in the final exam, it's not even a 3D problem if you think about it, because it doesn't involve 2 planes. It actually only involves 1 plane. Okay, so for this one specifically, what we're going to do is we're still going to follow those tips that I've given you, where you say, I will start in the triangle where I have the most information. And please, people, do not be scared to do some geometry. And when I say to do some geometry, it pretty much just means exterior angles of a triangle or interior angles of a triangle. Because we look at the triangle and we say, this seems to be the triangle that I should work in. Why? Because I've got the 2 sides. But currently, I don't have any of the 3 angles. Luckily, I've got that 45 degrees. So I can call this angle W1, and I can say in triangle FGW, angle W1 is going to be 180 degrees minus 45 degrees, and that's going to be angles in a straight line. So like I said, people, never ever ever be scared to do some Euclidean geometry. And this one's going to be 135 degrees then. Okay, so I've got that, which means in this particular triangle over there, I've got 2 sides and I've got an excluded angle, which means I've got 3 pieces of information, so I start there. Now, when I go here, there are quite a few options. I could go and I can calculate with these 2 sides and the excluded angle, I can go and calculate this angle over here. Right there. Why? Because this angle lies opposite 6. Now if I calculate this angle up here, it actually gives me way more information than I expected. And the reason it gives me way more information than I expected is because this is 90 degrees, this is 45 degrees. So if you again just go and you do your sum of angles of a triangle, you'll notice that this one is then also going to be 45 degrees. And the moment you've got this angle, which we're going to calculate just now, and you've got that angle, then you have this full angle over here. And then you can also go and calculate angle F. So there's lots and lots and lots of stuff that you can do in order to go and calculate that GH. Right, so first things first. We're going to start off by saying, I want to go and calculate this angle, so I'll call this angle G1 as well. And I'll say the sine of angle G1 over 6 is going to be equal to the sine of that 135 degrees over the square root of 116. And just to speed up a bit, I'm just going to do the calculation and write it straight down. So we're going to go and say it's that times that, but then I have to inverse sine it to get the angle. So I'm going to say it's 6 sine of 135 degrees divided by the square root of 116. And like I said, that answer is not my final answer. I still have to go and say shift inverse sine of that answer, and I get my angle, which is 23,1985. And just go dot 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 degrees, because remember, I'm not allowed to round off yet. I can only round off at the very end. So I'll just go shift store under A, so I know I can use that next. Now I've got this angle right there, and I've got that angle, which means I then have that overall angle. And you could then actually go, if you turn it sideways, you can see that because I've got this angle right there, and I've got this side right there, I can then go about calculating this side. Because I can now work in this 90-degree triangle where I say, this is going to be my adjacent side, which is what I'm trying to calculate. This is going to be my hypotenuse. So when I work with adjacent over hypotenuse, I've got cosine. So I can then go and say, in triangle, FGH, the adjacent side over the hypotenuse for that particular angle. Sorry, let's just do that again. The adjacent over the hypotenuse for that particular angle is the cosine, and it's specifically going to be the cosine of that 45 degrees plus that. So that plus 45 degrees. And that's going to give me the 68,19. So the cos of 68,198 ... degrees is adjacent, which is GH, which is what I'm trying to calculate, over the hypotenuse, which is the square root of 116. And then I can just go and say, oh, so GH is going to be equal to the square root of 116 times this, which means GH is then equal to 7. Did I do something wrong there? I think I forgot to do the cosine. Let's just first go and divide by the square root of 116. Sorry, the value was very big, and then suddenly I went like, I think something's wrong. Yes, I forgot to do the cosine. So I have to do the cosine of that angle first, and then multiply by that square root of 116. So that means GH is going to be equal to exactly 4 units. So yes, pretty easy and straightforward, but you had to go and you had to consider quite a few options in order to answer this question. So every now and again I'm going to throw in one of these IB questions, just so you have an idea of what the IB asks, rather than these very, very theoretical questions which you are now going to be doing some homework on. But like I said, the technique is valid, and you have to go and you have to be able to do all of these things just in case they could potentially ask you a question like this in your final exam. Okay, enjoy the homework.